Alright, so today we are going to be doing 1-3, which is going to be solving absolute value equations and inequalities. So, the essential question today will be, how can you find the solution of an absolute value equation or inequality? And our lesson target will be to solve the absolute value equations and inequalities using the properties of equality and inequality. Now, using the SCAM method, that's just the method that we talked about yesterday in solving or simplifying equations and inequalities. To get the absolute value by itself, if the absolute value equals a negative number, then there is no solution. Rewrite as two equations involving the positive and negative components. Use SCAM to solve the two equations or inequalities. Check your solutions. You might get a solution that does not exist. In math, we call this an extraneous solution. Okay? Extraneous solutions are solutions that come out, but they don't really exist. So let's talk a little bit about an absolute value and when we're going to get no solution. So a lot of people said they were really unsure about what an absolute value is and what the properties are, so I just want to give a little brief history on that real quick. So in that scenario that you're not sure, let's talk about it. So say I have a number line. You can write this if you want, but you don't have to. Say we have a number line, and on that number line we have 0, and we have -1, and we have 1 on the other side. Now the absolute value is one's distance from 0, the measure of distance from 0. Now we know that in math distance is always
from 0?
Yeah, from 0, or it's never negative, right? So it's always positive. Distance is always positive. Even if you travel a different direction, you're still going at a positive distance, right? So distance is always positive. So this is 1 unit of distance, and this is also what? 1 unit. So the distance from 0 to -1 and the distance from 0 to 1 is the same distance. That's why the absolute value of -1 is 1, and the absolute value of 1 is also 1. So that's the reason that's behind what the absolute value is. So hopefully that will give you a little bit of better understanding when we get no solution. So I just want to put that out there. Does anybody need any more time on the fill in the blanks? Alright, we're going to move on to example 1. So for example 1, I'm going to zoom in a little bit so you can see a little better. Now the very first thing you always have to do with these particular absolute value equations and inequalities, you cannot distribute into any absolute value like you can with the parentheses, okay? Very important. Cannot distribute. So what we have to do is we have to always isolate the absolute value, get it by itself. Any suggestions on how we could do that here? Yes?
We could add 6 to both sides and divide by 3.
Very good, exactly right. We're going to add 6 to both sides. That's going to leave me with 3 times the absolute value of 2x minus 3 is equal to 27. And then like Kyle said, we're going to divide both sides by 3. That's going to give me the absolute value of 2x minus 3 is equal to 24. I'm sorry, not 24. What am I saying? 9. So we get 9. Now here's where things get a little bit different than solving a regular equation. With an absolute value, there's a situation where inside this absolute value, if this inner part comes out to be -9, it's still going to come out to be 9 as the answer, right? Or in the situation where if we get 9 for the inside, it's also going to come out to be 9. So there's 2 different scenarios that can work to still give us 9. So we have to account for that in our solution. So you're always going to have one positive version and one negative version of your equation. For the positive version, you're always just going to drop the absolute value bars and rewrite the equation as is otherwise. Okay, that's the way you do it. For the negative version, you're always going to multiply the left side, it's lagging, sorry, by -1. And everything else stays as is. Okay. So is everybody good with that step there? Understand what I was saying? So now in each of these cases, we're going to solve each of these for those individual variables. We're going to solve each of these 2 equations, okay? So over here, I'm going to add 3 to both sides. That's going to give me 2x is equal to 12, which means that x equals what? 6. Now over here you have two choices on how to solve. You can either distribute the negative or divide both sides by -1 to get rid of it, right? So I divide both sides by the -1. If you did it differently, that's okay. You'll get the same answer. And then what would be my next step? Add 3. And then do what? Good. Which comes out to be? -3. So these are my two possible solutions. Now we haven't verified these solutions yet. So these solutions always need to be verified. Anybody want to raise their hand and tell me how you think you verify them? Yeah, we replace the x back into this. So we go back to this one right here, and we plug x back in to make sure each equation works. So I just like to do it mentally. You can write it out if you want. So I'm going to plug 6 in mentally here. So what's 2 times 6? 12 minus 3? Absolute value of 9 is 9. Is that true? This is true. It's verified. The next one, we're going to plug in -3. What's 2 times -3? What's -6 minus 3? Is the absolute value of -9 9? Yes, both of those solutions are verified. That means they're both true solutions. Is everyone good with that? Okay. So let's go ahead and try number 2. So the first rule when you're dealing with an absolute value equation or inequality is to ensure that the absolute value is by itself on one side of the equal sign. Do we need to do any work to get that done here? No, it's already done for us. So we're ready to move on to the next step, which is writing the positive and the negative version of my solution, or my equation. So the positive version is simply where we just drop the absolute value bar and we write the equation as is. The negative version is where we multiply the left side by a -1. Don't forget your parentheses because you will have to distribute onto every term. Now we're going to solve each of these equations individually. I'm going to do that by getting the x's to one side by subtracting x on both sides. What's 2x minus x? X. So that one's already solved. Now over here on the other side, I'm going to divide both sides by -1. That's going to give me x plus 6 is equal to -2x. Now to finish solving that, I am going to subtract x on both sides. That's going to give me 6 equals -3x. And then I'm going to divide both sides by -3, which gives me x equals what? -2. Very good. So these are our two possible solutions. Now we have to go back and verify these. So does anybody have any questions about the equations themselves here, how I solved them, anything like that, before we do that? Everybody see what happened there? Okay. So to verify these, I'm going to replace the x with whatever we just found. So in this case, I'm going to try it with 6. So I just rewrite the equation where I replace all of the x's with 6. What's 6 plus 6? Absolute value of 12 is? 12. Is this side also 12? 2 times 6? Yes. So we can verify this one. Now let's try the other one. So the other one has -2, right? So if I plug in a -2 instead, let's see what happens. What's -2 plus 6?
4.
Good. Absolute value of 4 is?
4.
Over here, what's 2 times -2?
-4.
Can I verify this one?
No.
Is -4 equal to 4?
No.
No, this one's rejected because it doesn't check out on both sides. So we call this extraneous. So if I ever ask you what is the extraneous solution, that's the one that didn't check out when you plugged it back in. Does anyone have any questions about that? Yes?
Is the negative equation always going to have a negative answer and same goes with the positive?
No, not always. But good question. Anybody have any additional questions about this before we move on to the last equation we're going to do, and then we're going to move to inequalities? Yes?
So
So for every one with like absolute value, you're gonna always have to do like a positive and a negative solution?
Yes, there are a few exceptions where we don't have to do the math, and you're going to see that on the next problem, but typically yes. So let's go ahead and try the next problem. Now in order to do this problem, we're going to have to isolate the absolute value. How do you suggest we do that? Not minus. Divide. Everybody understand why it's divide and not minus? It's multiplication, so we reverse multiplication with division. There we go. So looking at this problem, so before you do anything else, I want you to stop and think about this one for a minute. Sometimes you're not going to have to do all the math. There's a little bit of a trick here. The absolute value of something, they're telling me, is equal to a negative number. Is that ever possible in math? No, because the absolute value must always be positive. So could it ever equal a negative number?
No.
So does it matter what I plug in for m here? It's always going to be something that's positive, which does not make sense. So this is going to be no solution. So if you're wondering, say you didn't catch that in the beginning, you're just going through the rhythm, doing the problems. What do you think would have happened if we went through the whole procedure of the negative positive?
We would just have two non-right answers.
Good, we would have had two extraneous solutions. So I just want to mention that the process works regardless. It just saves you the time. You don't have to take the detour. You can just take the shortcut if you do it this way, okay? So it wouldn't be wrong to do all the steps. It would just be unnecessary. So does anybody have any questions about that? All right, let's go ahead and look at the inequalities now. So let's talk about solving absolute value inequalities. It's a little bit different. Same but different. So there's a few fill in the blanks for this one. Now I want you to add a little thing here. The third and the fourth situations require, it's lagging, sorry, require solving, okay? That's what I'm trying to write, but it's just not cooperating. So the third and fourth step require solving. So before we go ahead and try to apply any of these rules, let me talk you through the process. What's up? Oh, it says all real numbers for the second one, and the first one says no solution. So when we're doing an absolute value inequality, the procedure is pretty much the same to begin with. You always have to get the absolute value by itself. Regular inequality rules apply, so if you're dividing by a negative, you have to flip the sign and all that. Now, the results that you get can help save you some time. If you get one of these two first results, you don't have to solve anything. So if you follow these procedures, you can avoid extra math, right? So let's talk about this situation. Think of A as some number or expression, and think of B as some number or expression. It doesn't matter what they are, just think of it as in an abstract way, okay? If the absolute value of something is less than a negative number, is that ever possible to happen? No, because absolute values are always positive. Therefore, it's never going to be less than a negative number. Every positive number is more than any negative number, right? So, no solution if that's the case. Second situation that can happen. The absolute value of some number is greater than some negative number. Isn't that always true?
Yeah.
Yeah, because any positive number is always bigger than any negative number. So no matter what the positive number is, it'll always be bigger than a negative, which means that the solution's all real numbers. Meaning you could plug any value in for A, and it would become positive because of the absolute value, and always be bigger than any negative number. Does that make sense to everybody what I'm saying by that? Okay. Now these other two situations have a little more nuance, okay? These two situations require us to solve further to really evaluate what the situation is. So the absolute value of something is less than some number. That can happen if the number's positive, right? And the same down here, it could be greater as well. Now to note, this is very important, these rules also apply when we have the equal sign under the inequality. So like if this were less than or equal to, greater than or equal to, less than or equal to, greater than or equal to, the same rules apply regardless of if it has the equal sign underneath. So just be aware that when I'm talking about them, they apply as well. Okay? So let's go ahead and try some examples together. We're going to do one of each type so that we can really see what happens each time. So the first type we're going to look at, the very first thing we need to do is isolate the absolute value. How do you suggest we do that here? Not yet. Good, we're going to subtract 3 first. That's going to give me 2 times the absolute value of x plus 1 is less than or equal to negative 10. And then, like you all said, we're now going to do what? Divide by 2. What's negative 10 divided by 2? Negative 5. Now, somebody in my other class asked me this, so I just feel to mention it. The reason I didn't flip the inequality is because I didn't divide by a negative number. If you divide into a negative number, that's not the same as dividing by a negative. You only have to flip it if you divide by a negative. Does everybody understand the difference between those two situations? Okay. So let's look at that chart that I talked about on the last slide. Which situation do you think this one is? Who says no solutions? Anybody? You're right, it is no solution. Anybody know why it's no solutions? Very good. Because of the inequality. There's no possible way that I can plug in any value for x that's going to make this less than negative 5. Because the absolute value of anything is always positive, which will never be less than negative. You may. Alright, any questions about this one? Are we ready to move on to the following one? Alright, let's try the next one. So our first step is to always isolate the absolute value. What's going to be the first step in doing that? Good, we are going to add 1 to both sides. That's going to become 3 times the absolute value of x plus 1 is greater than what?
15.
Negative 15. Next step is to divide both sides by, which leaves us with the absolute value of x plus 1 is greater than what? Negative 5. Take a look at your chart and determine which situation you think this one is. Good, this is all real numbers. So the reason this one is all real numbers, it doesn't matter what the absolute value comes out to be, because it will always be what? We can guarantee that it's always what?
All real numbers.
Not all real numbers for the absolute value, positive, which means that for any situation, it's always still going to be greater than negative 5. Even if it's 0, it's still greater than negative 5, right? So that's the reason. So is everybody good with that? Okay. Let's go ahead and move on to the next. So now we're going to do 2 situations where we're going to deal with the third and the fourth rule. Okay? So the first thing I'm going to do, as we keep doing, is get the absolute value by itself by dividing both sides by 2. That's going to leave me with the absolute value of x minus 3 is less than 4. Now that we're at the stage where we have the absolute value by itself, I want you to determine, what do you think? Is this one 3 or 4 situation? 3. This is situation 3, which situation 3 and 4 you treat pretty much the same until the very end of the problem. It just requires you to solve it like we did with the equations. So, when you get to situation 3 and 4, you're going to do a positive and a negative version just like we did with the equations. I wish I wasn't lagging, it's the worst. Okay, so for the positive version, you're simply going to rewrite your inequality without the absolute value sign. For the negative version, you're going to put a negative 1 on the outside of the left side, parentheses around it, okay, just like that. So is everybody good with how I got those 2 inequalities that I'm going to solve? Now I'm going to proceed with actually solving each of these. So I'm going to add 3 to both sides on this one, which is going to give me x is less than what?
7.
Very good. Now over here you have 2 choices in how you want to solve. You can distribute the negative, or you can divide by the negative 1 to get rid of it in the beginning. That's going to become x minus 3 And what's going to happen to my inequality sign?
It's gonna
Flip. Flip.
Flip, because I divided by a negative, and I'm left with this, but I'm not done solving. What's my next step?
Yeah, 3.
Add 3 to both sides. What's negative 4 plus 3?
-1.
Good. So those are my two situations. Let's talk about them. So, x is greater than -1, but less than 7. So that's a compound inequality that looks like this. And whatever your signs are, if they have an equal sign with them, if they don't, that's what you bring down to this one as well, okay? So x is between -1 and 7. Those are the numbers you need to put on your number line. So -1, 0, 1, 2, 3, 4, 5, 6, and 7. So you're going to put all those numbers on the number line, okay? So is everybody with me so far on what I've done?
Yes.
Now we have to determine if they're open or closed circles above each. So above the -1, open or closed? Open due to the inequality without the equal sign. What about above the 7? Open. Now this is a compound inequality that's joint, which means all the values for x fall between -1 and 7. But are -1 and 7 included? No, because of the open circles. So any x value between -1 and 7 that are not -1 and 7 will make this statement true. Make sense? All right, we have our last scenario, scenario number 4. So first thing we do, as always, we get the absolute value by itself. Is everybody pretty good with this step so far?
Yeah.
Okay. Just go a little faster on that. That's why I gave you that review of equations and stuff in the beginning, because in this class we're going to be doing a ton of that just before you even get to the premise of the lesson. So that's why it's so important to be proficient in that. So we get to this stage right here. I determine that it's scenario 4. If you're not sure, take a look at scenario 4 and see how it matches it. Scenario 4 requires math. I'm going to have a positive and a negative version. My positive version, I simply drop the absolute value sign. My negative version, I put a -1 on the outside of parentheses on my left side. I'm now going to solve each of these inequalities individually. I do that by subtracting 2 on both sides, giving me x is greater than or equal to 1. And on the opposition here, I'm going to divide both sides by -1, giving me x plus 2 is, what's going to happen to the inequality sign? Flip and become -3. And if I subtract 2 on both sides, that gives me what?
X equals -5.
Yep, x is less than or equal to -5. So those are my two inequalities. Let's think about these for a second. X is less than -5 or greater than 1. So what that means is it can be either down here or up here. It's nowhere in the middle. Okay? So this is what we call an or inequality. Okay? An or inequality. So x is less than or equal to -5, or x is greater than 1. So how that works is we put both of these on the number line. Oops, I meant to put, sorry. So it should look something like this. And now we determine the type of circles. So what are we going to use for the -5? What kind of circle? Good. And what about for the 1? Good. Now they don't have to match, just the examples we've done have happened to match, so just be aware of that. Oh, is that the end already? Oh, I was going to say, what's up? Yeah, go ahead. So Can you wait like literally 3 seconds? We're gonna finish. Okay. So we just have to determine which way the arrows go now. So x is less than or equal to -5, which means it's gonna go to the left. X is greater than 1, it's gonna go to the right. So those are the two arrows. That's why this whole section, if the number is between -5 and 1, it's not going to work, but anything less or more will work. Now before you go off on your own, I want to show you the graph of this to explain it in more detail. See how on the graph, if I plug this equation in, I'm almost done. So see how right here, this whole section of the graph is not filled in? Because it can either be less than or equal to -5 or greater than 1. So everybody understand the difference between an or and an and inequality. All right, Connor, you can go now.